Okay, on this problem, you're asked to find the area of the surface generated by this curve that's parametrically defined. X equals t plus 2 on the square root of 5, y equals t squared over 2 plus 2 square roots of 5t plus 3 on the integral from negative 2 square roots of 5 less than or equal to t, which is less than or equal to 2 square roots of 5. So you should have your formula kind of memorized by now. You're going to need dx dt and dy dt. So dx dt is going to be just the derivative of t plus a 2 on the square root of 5, so that's just 1. And dy dt is equal to the derivative of this. Well, 2t, the derivative of 2t divided by 2 is just going to be t, and then plus that'll be just 2 on the square root of 5. So your integral will be, the 2 pi will be in front, and you're going to integrate from negative 2 on the square root of 5 to positive 2 on the square root of 5. The x, which is t plus 2 on the square root of 5, onto the square root of dx dt squared, which is 1, plus dy dt squared, which is t plus 2 on the square root of 5 squared, and then, we'll put that like that, and that's going to be dt. So cleaning up inside here, when you expand t plus 2 on the square root of 5, when you expand that out, you get t squared plus 4 square roots of 5t plus 2 times the square root of 5 times 2 times the square root of 5 is 4 times 5, which is 20. And then you have to add that 1 from there. And so this is going to be 2 pi integral negative 2 on the square root of 5 to 2 on the square root of 5 t plus 2 square roots of 5. And then inside here is just going to be t squared plus 4 square roots of 5t plus 21 dt, because I added the 1 to that. All right, then you can actually do a nice u substitution here. If you let u equal t squared plus 4 on the square root of 5t plus 21, then du will equal 2t plus 4 on the square root of 5t. And what's nice about that, no t, because it's a derivative. And what's nice about that is that you can factor 2 out, and you're going to get 2 plus 2 on the square root of 5, which is exactly what you have right here. And so you realize that you have everything you need. You just want to do du over 2, or 1/2. So the 1/2 is going to be 1/2 du is equal to t plus 2 square roots of 5 dt. So you have a perfect substitution there. And the 1/2 will cancel with the 2 out front, so you're just going to have a pi in the front. You need to change your limits of integration when x is equal to negative 2 on the square root of 5, or really when t is equal to negative 2 on the square root of 5. U will be equal to, negative 2 on the square root of 5 squared plus 4 on the square root of 5 times negative 2 on the square root of 5, and then plus 21. And let's see, this is 4 times 5, which is 20. And then you have 21, so that's 41 plus, here this is negative 8 times 5, which is negative 40. So u is 1 there. And then when t equals 2 on the square root of 5, you do the same thing, but you don't get to have the negative. So you got the 4 square roots of 5, and then it's going to be 2 square roots of 5, and then plus the 21. So this is going to clean up to be, this still cleans up, this is 4 times 5, so that's 20, and the 21 is 41. And then you have 4 times 2 is 8 times 5 is 40, so that's 81. So it's actually really nice limits. So that being said, all of this cleans up to be just pi times the integral from 1 to 81, and that was our, took care of in our substitution, so we just end up with the square root of u du. So again, because we had the 1/2 du, so that canceled with the 2. And then this is just a simple integration here. This is u to the 1/2, so you add 1 to the exponent, put over it, so that's going to be 2/3 u to the 3/2, evaluated from 1 to 81. And so, so you have pi times the 2/3, and then this is going to be 81 to the 3/2 minus 1 to the 3/2. And 81 to the 3/2 is the square root of 81, which is 9, and then cubed. So pi times this. Okay, so this is going to be 9 cubed minus 1. And 9 cubed is 729, minus 1 is 728, and then 728 times 2 is 1456. So you get 1456 pi over 3, and 3 doesn't divide into 1456, so you do get the correct answer.